Hello, good afternoon, and welcome to Foreign Affairs. Today we have a special occasion, and we're going to talk about the water resources of the world. And let me just get started. All right, so how much water do we have in comparison with the whole of Earth? We don't have all that much. Okay, there it is. So that is how much water we have in comparison with Earth.
Fresh water?
No, all water.
All water.
All water, including oceans. That little thing there is the fresh water that we have in comparison with the Earth. And that little thing that you may not barely see there, that is how much surface fresh water we have. So you can see that it's not a lot.
Are those spheres? Are they all spheres?
Yeah.
Well, on this diagram, yes, they are. Yes. So how is it? Where is all this water? Well, you can see that almost 97% of the water is oceans, and there is another extra 1% of saline brine water. And fresh water is only about 2.5% of all the water that we have.
But that includes frozen water.
That includes all the fresh water, all the water that is not salty water.
Yeah, but
Yes.
that includes frozen
It does.
because of that 2.5%. 1.75% is frozen.
Well, we'll get to that.
And
In
that other
fact, the next step.
the other saline water, does that just mean?
All this is saline water,
Brackish.
and
Brackish water
2.5%.
where water,
Yeah.
it's a mixture of fresh water and salt water, I guess.
Well, all of the oceans and all the brackish waters in the world are about 97.5%.
Okay.
So everything that is briny or salty.
Okay.
2.5% is fresh water, and of that, you see, 70% roughly is trapped in glaciers and ice. And 30% of it is groundwater, aquifers, and so on. And only 1.2% is surface water. Okay, so all of this is fresh water now, but most of it is really in ice. A lot of it is in the ground, very little in the surface. Of the 1.2% in the surface, most of it really is in permafrost and ice. And lakes is only 2% of this 1.2% of fresh water. And look at the rivers. It's only 0.5% of all the fresh water is in rivers. So it's very little. Atmosphere has 3%, and living beings, well, they have about 0.26%. So this is the water that we have. And so what do we do? How do we use the water that we use? How do you do? Okay. So this is how we generally use the water. Most of it is really used in agriculture. Some of it is used in industry and mining and the water and the food food production and so on. And the rest of it is used in domestic use. Toilets, washing, showering, etc., etc. You can tell that the developing countries, of course, they use more water for industry. And developing countries, well, they use a lot of water in agriculture. So this is what we have, and this is how we generally use the water. Let me get started with the bad news. And the bad news is that, well, we have been using water very increasingly with time. And especially in the last 10 or so many years. Most of the water is used by Asia. They have most people. Then North America. This is Europe, South America, and Africa, and so on. So this is the use of fresh water now. This is fresh water consumption has been increasing quite a bit in the last 100 years or so. And this is how the increase shows up in terms of the use. It's always mostly used in agriculture. And as time goes by, we use more in industry and also in domestic use. Now this picture here is a very interesting one because in terms of the agricultural use, for example, this dark green is the withdrawal, is the amount of water that we take in order to use. And the smaller one is the amount we actually use. So the difference between these two is the waste. And as you can see, during time, as time has gone by, we have been using more and more water. Actually, we have been extracting more and more and using more and more, but the gap between the two has been increasing. In other words, we're wasting an enormous amount of water.
Is that from evaporation or leakage?
We'll get into that and a number of the ways we waste that water. So the gap of how much we take out and how much we actually use is enormous. Industrial, the same. Actually, it's worse because this is a small in the 1900s, very small amount extracted and much less used or consumed. The difference again is waste. And you can see as time goes by that there is an enormous gap there between what is extracted and what is actually used. And same with the domestic. Now this last is about reservoirs. We have been increasing the number of reservoirs as time goes by. And of course, the surface is bigger and bigger. And so the evaporation is also bigger. So we're losing all this water through evaporation now. So here's the place where we can actually make up the water that is lacking in places by saving water. For example, do you know in the domestic use, what is the biggest waste of water? It turns out that it's leaks. And it's not just leaks in your home, but it's leaks as the water gets to you. And I'm not really talking about the United States because the United States really has a pretty good system where the leaks are not that bad. But if you go to other countries, developing countries particularly, the leaks are just absolutely enormous. They lose an enormous amount of water, and that is what is seen, well, actually here, the gap between what is extracted and what is actually used. So that is the place where we can make up the water that we need. Now, not only do we use this water and waste it, but the sources of the water have been decreasing. Take a look at this line, for example, in Brazil. Brazil has an enormous amount of water. Of course, the whole Amazon basin is there, but they have been cutting so much jungles and eliminating so much water resources or sources of water that their renewable freshwater resource has been decreasing enormously. You can tell that the United States has also been decreasing, but not quite that much. And in fact, this is the world line here. In the world, the renewable freshwater resources have been decreasing with time. A recent New York Times article from October talked about the underground, the aquifers in the United States, as an example. A wealth of underground water helps create America. This you cannot see too well, I'm afraid. There's a little, some darker spots
Yeah,
here and there. There is a lot of water under the surface in the United States, the aquifers, there's a lot of it. However, what has happened there's this. Nearly half the sites have declined significantly over the past 40 years as more water has been pumped out than nature can replenish. So all of these dark areas are the places where more water has been extracted than nature has been able to replace. So the United States is losing its resources, its water resources from the aquifers. You can notice that even Florida has that problem, where we are taking out more water than nature can replace. And furthermore, in the past decade, 4 of every 10 sites hit all-time lows. And the last year was the worst yet. Now, this is an article again from October of this year. And these areas here, particularly California, Texas, and this area here are the worst in the nation. But Florida also has, a number of sites that have hit all-time lows. So this is a matter of concern for the United States, but even for a wet state like Florida, the Florida aquifer, the source of 90% of the state's drinking water, is being depleted as water demand from urban areas and unsustainable agricultural practices continually increase. Unsustainable agricultural practices. And this is from 2022. So even wet states have this problem. Now, worldwide, the stress of obtaining water is, as you can see here, no stress in South America, mainly. Now, there is a stress, by the way, in this area, which is very dry, but it's not pointed out here. The United States and Mexico has low stress, but there is stress. China, of course. But the most stress is Northern Africa. And of course, this area of the Near East and the Central Asian countries here, they are very critically stressed, some of those countries. And there have been no news about how stressed they are now and then. Here is one. This came out in New York Times again, June 21 of this year. It talks about Iran. Some are chasing the last drops of water in Iran. This is the southeastern part of Iran, but it's running out of water practically. And people are leaving the area because they cannot just live there. The dried out river, there's a river there. The country is a water bankruptcy trap, and it cannot get out, according to that. So not only is it bad enough that we're increasingly using up the water, but there is something that came on top of that, which is global warming, that essentially exacerbates the disappearance of usable fresh water. Not disappearance, but the decrease. What the small print there says is this. Climate change is exacerbating both water scarcity and water-related hazards, such as floods and droughts, as rising temperatures disrupt precipitation patterns and the entire water cycle. So this is another problem for for having enough water on Earth. This is an added one to the excessive use that we have. And finally, we have another, oh, sorry. So there's an increasing evidence that global warming has accelerated, oh yes, over the past 15 years rather than continue the gradual steady pace. You would think that the global warming is a straight line, but it's not. Actually, it looks like this. Where it is a straight line here, is growing, but then it started growing about 1960, 65, 70, started growing more steeply, and then it changed slope once more in the last 10, 15 years. So the global warming is accelerating. So on top of the excessive use, on top of the global warming exacerbating the problem, we have this other problem, which is population growth. And it affects water availability and scarcity. We are here now, 8 billion people, but in 50 years, we will have 30% more people. We'll have 10.5 billion people on Earth. That's the projection. So these people need food, need water, so this is another problem. Okay, so there are three major problems. One is excessive use, two is global warming, three is the population growth. Those are the bad news. Let's turn to something more cheery, some good news. Okay, regarding the population growth, let me start with that. The good news is that the annual growth rate of the world population peaked out in 1963 and is crashing. It's going down steadily, very fast. So that about this time in 2085 or so, the world will start losing population. So that's why there is a peak here in expected 2086 of the total population on Earth. So population will be decreasing after that. Well, I guess this is good news. With respect to the other problem, the climate change, well, there's a lot that you have heard, you have read in the papers, and you hear in the news, electric cars, solar, and wind energy, and so on. And a lot of countries are actually doing their part, they're participating. Even small ones. This is one that came out in New York Times. When was it? October 10 of this year. How the tiny nation is replacing fossil fuels and renewable power. It talks about the Maldives Islands in the Indian Ocean. And they're replacing oil for solar and wind energy. A small nation of 500,000 people, but they're doing their part. More than that, Denmark has a huge program now of green hydrogen. What the idea here is that they're going to convert the eolic energy, the wind energy, in order to electrolyze salt water and divide it into hydrogen and oxygen. Water, of course, is H2O. When you electrolyze it, you get two products, separate products, hydrogen gas and oxygen gas. Hydrogen gas is a very, very valuable base for numerous industrial products, methane, methanol, fuels, fertilizers, and a bazillion other things. So the Danish plan is to extract the hydrogen from water with eolic energy, and then use the hydrogen to make all these industrial products, which is a very nice idea. But they're not the first ones to come up with that idea. It turns out that the Biden administration just recently awarded $7 billion for 7 hubs across the United States in order to research the ways to harness, to convert water into hydrogen and oxygen, and then harness the energy of hydrogen and use the hydrogen for other products. This This came from the bipartisan 2021 infrastructure law. And the news here is in October last month, 2023. So also, the International Energy Agency recently estimated that $1.8 trillion will be invested in clean energy, like renewables, electric cars, heat pumps in 2023, up from 300 billion a decade ago. So there is a huge shift of funds to make renewable energy. So this is the good news about about the population growth. The good news about confronting the change. Climate change. So what are other organizations doing about the water itself? There are international organizations, national organizations, local ones, and others. So we'll go through some examples. The United Nations in 2015 came up with the UN Sustainable Development Goals. And you can tell, number one, no poverty by 2030. Zero hunger by 2030. Good health and well-being, quality education, gender equality, clean water and sanitation. That is specifically about this issue, the issue of water resources in the world and what to do about it. And so I'm not going to go through the rest of these, but I do want to go through some of the goals that this that the sustainable goal has for water. So by 2030, the world should achieve universal and equitable access to safe and affordable drinking water for all. That sounds pretty good. Another goal is to achieve access to adequate and equitable sanitation and hygiene for all, and end open defecation. It seems to be a big problem in the rest of the world. Paying special attention to needs of women and girls and those from vulnerable situations.
You don't have a sewage system in your country.
That's right. Another one, by 2030, improve water quality by reducing pollution, eliminating dumping, minimizing, reducing hazardous chemicals and materials, and so on. One more. By 2030, substantially increase water use efficiency across all sectors and ensure sustainable withdrawals of supply of fresh water to address the water scarcity and substantially reduce the number of people suffering from water scarcity. There are a lot more that I'm not going to read because there's a lot more. But there are these, other water resource management, protect and restore, help developing countries particularly, and so on and so forth. Now, these really sound like sort of lofty goals. And when you think about the UN, you probably say, well, this is probably wishful thinking. Nothing serious will happen, no matter what they say. Well, you would be wrong. You would be wrong because, some things have happened. And it was under the direction and help of the United Nations. For example, in 2020, 74% of the global population had access to safely managed drinking water services, up from 70%. Well, it doesn't sound like a huge number, but it's in the right direction. Between 2015 and 20, the population safely managed sanitation increased. Population with safely managed sanitation increased from 47% to 54%. And the population with access to hand washing facilities with soap and water in the home increased from 67 to 71. Again, it doesn't sound like a huge change.
Yeah, but those are significant.
But Again, it significantly does.
You're talking about a whole lot of people.
That's right.
The percentage is small, but a whole lot of
It's a
people.
whole lot of people, that's right. Water efficiency worldwide rose by 12%. Assessment of rivers, lakes, and aquifers in 97 countries shows that 60% of the water bodies have good water quality. This is the research that UN has done. From 2015 to 2020, the population practicing open defecation decreased by 1/3, from 740 million to 500 million. And the world is on track to eliminate open defecation by 2030. That for the rest of the world is a very important thing, of course. So you know, this is all positive. They're doing things. So this is in the international level. So what about the United States? Well, we started a lot earlier than this. And the Clean Water Act in 1972 is about EPA, sets up standards for drinking water quality and monitors states, local authorities, and water suppliers to enforce those standards. That was very important, and we're enjoying the effects of that. And the other one, Safe Drinking Water Act, 1974, again, it's EPA. It regulates for contaminants and so on, and they essentially reduce public health risk. So the United States has been doing this for some time. More recently, in the United States, the Sustainable Groundwater Management Act of 2014. Now, this is a California law only. It requires local agencies from groundwater sustainability agents to form groundwater sustainability agencies, which are to develop and implement groundwater sustainability plans to avoid undesirable results and to mitigate overdrafting within 20 years. So I guess that they knew that the aquifers were being depleted and they acted. I don't know what they're actually doing right now, but this is a very positive measure in that direction.
Yeah, so you have rights if you drilled for water for agricultural purposes. But what that law did was to change how far, if you needed to put in a new well because you needed greater depth, you couldn't do it.
Yeah.
Unless you got approval from California. And they actually pretty much regulate the usage of that water.
It's a good thing.
Yeah, yes and no. No, I mean, one could go into the why, not so much. You can't even build a reservoir on your private land because the rain belongs to the state of California.
All right. Well, all right, let's go on. And Senator Ron Wyden, he's from Oregon. He must have read the New York Times article because he came up with this. He's the chairman of the Water and Power Subcommittee. He said the federal government need to work with states to address what is called the groundwater crisis. So maybe something will happen in the on the national scene about protecting the aquifers of the United States. So this is what has been done already. I have read that there is clamor, and I think it's a right idea to do this. The partial solution across the board is to raise the price of water, including aquifer water. Now, what do you mean by including aquifer water? Well, just like Ed said, you know, you have a property and you dig a well and you take water out and you use the water for whatever it is, agriculture or mining or whatever. Well, if he is using, that person is using the water of the aquifer, which is a common good. And so the idea is that even if he's taking water out of his own property, he has to pay for it because it comes from a common good. So anyway, this could be a partial solution, but there are other things. Apart from global organizations, governments, what else can be done in agriculture and industry and domestic use? Well, agriculture is the area where most water is used and where most water is wasted. This is one way of wasting water. It's called flood irrigation. There's a lot of places where they use flood irrigation. Another method of irrigation is spray irrigation. You must have seen it because you drive across the country. And that is a little better than the flood irrigation, but still there's a lot of waste of that. Another method is furrow irrigation. Again, it's a little bit better, but it still is a lot of waste. So the idea is to change these technologies, these mechanisms of using water in agriculture. Do what? Well, replace it with good technologies. Like what? Like, for example, Israel's drip irrigation technology. They have used this for, I don't know, 50 years or more. And it works for them, and it's economical for them. Other things that should be done is recycle. That is not done a lot today. Capture and reuse the runoff. Farmers can capture the runoff in ponds and then pump it back to recycle it. Another one is collect the storm water and use that. But more than that, you can use new technologies, like, for example, digital water management. So what does that mean? Well, it means technologies such as sensors, artificial intelligence, etc., enable water quality and quantity control, as well as remote asset management. For example, the soil moisture-based control technologies. So there are the sensors that tell you whether the plant needs to be watered or not. So you water it only when it needs to be watered. Another example is rain sensors. Well, you're in a couple of 100 miles away, possibly, where you read these sensors. You don't know if it's going to rain or it's raining over there, but the sensors will tell you. You send a signal that when it rains, you don't water the plants anymore. So there are these sensor ideas that would work, that would make you save a lot of water in agriculture. A little bit more sophisticated is something called the GIS, the Geographical Information Systems. What they do is that they visualize a whole area, a big area, and model scenarios to identify problems and prevent damage. For example, by knowing the geographical location of farms using specific fertilizer, the GIS analysis of farm locations, stream locations, elevations, and rainfall will show which streams are likely to carry that fertilizer downstream, and then make the appropriate decisions. The way it works really is by creating software that will put in the data layer by layer. This is the buildings, vegetation, and the integrated area. And everything is computerized in such a way that you know where every drop of water is and when. Okay. Another good new technology is vertical agriculture. Now, this is the agricultural process in which crops are grown on top of each other, rather than traditional in horizontal rows. Growing vertically allows for conservation of space, resulting in higher crop yield per square foot of land. And it allows for conservation of water resources. and it often incorporates controlled environment in agriculture. So here's an example. This is a real building. It's in Jackson, Wyoming, and they produce vegetables vertically. Here's another one. This is the Plenty Company. They claim that the water consumption in this form of doing agriculture saves 95% of the water. 95% of the water. And I have read that there are companies that are thinking that they can do it up to 99% of the water that's saved. In other words, they will have very little water that is recycled constantly. They don't need enormous amounts of water. Here's an example of how this would work.
That's hydroponics.
Another new technology that has been studied for a long time and is still being studied is desalination of seawater. At the present, the desalination technologies are rather expensive. And so new technologies really are needed in order to get this technology to work better. Also, there is a problem disposing the concentrated salty water. Another technique to save water is to stop evaporation somehow. Let me show you that this is a picture of the cumulative reservoir storage. From 1950 on, there was building an enormous number of reservoirs. And as I said, the surface of that water is larger and larger, of course, and the evaporation is larger and larger. So at this time, in 1960 already, or a little bit after 1960, the evaporation is more than all the water that is used in industrial and domestic consumption. So that's an enormous amount of water that is being lost. And so what to do about it? Well, here is one company in Denmark that is doing something about it, and it's covering the water. Water lilies. They have water lilies covering the water, and this saves from evaporation an enormous amount of water. And another option is to have these floating covers. They're called Rumbo, Hexo Shield. And you can see that, you know, they float, and but they're expensive. They're plastic, they're a little bit expensive. Other techniques would be underground storage in caves and other artificial places. Other chemicals that would retard the evaporation. There are many of these chemicals, but again, they are expensive. Windbreakers, they help a lot because wind takes away a lot of the surface water. And to promote ecotourism, and that essentially brings in funds in order to be able to pay for these new technologies and so on. So the other industry that uses up an enormous amount of water and waste is the industrial use, the mining, food processing, power production, car washing, and airplane de-icing, even that is. And fracking, I didn't know that fracking required that much water, but fracking requires an enormous amount of water. And the new technologies that they have been developing with time require more and more and more water in order to frack the resources. And I think that this is one of the major reasons why the aquifers in Texas are being depleted so fast because of the fracking. And so I don't know what can be done about this particular issue, but this is one of the problems. So giant new oil and gas wells that require astonishing volumes of water to fracture bedrock are threatening America's fragile aquifers. Well, and I think I'm going to stop at this point and maybe talk a little bit about this topic. So thank you very much for listening. Oops, what happened? There.
Yeah, thank you. Do we lose what? Do we lose water to outer space? No.
I don't think-
Is the water changed to other compounds where it cannot come back out of? So where's the water?
Comes down.
Goes into clouds. and-
So is the problem, it doesn't get into the aquifers fast enough?
Yes,
Yeah, the rate of
It's not that
withdrawal.
we don't have enough, the water is there, it doesn't go away.
It's time. Is anybody on the Zoom?
A couple of people, yes.
Okay, it's time. So the aquifers, but it's also pollution. There are a couple things that
Yes,
you said that it was in, less developed countries that, there's a lot of water that's wasted via the distribution of water.
aqueducts.
Okay, I mean, I'm just talking about in cities. Well, do you know that 28% of the water in London is lost to waste? That in Montreal, it's 40%. Okay, in Delhi, it's 53%. It's not just accidental leaks, it's theft in poor countries. Okay, what's that? That comes from, well, it came from a long survey done by the economists, and they listed all the different sources and books that they depended on. There were like 30 books. Okay, but so, but I just wanted to, one of the problems is, as you mentioned, agriculture. And by the way, the Israelis, the drip irrigation was created by an American Jew who moved to Israel, and that's where it really took off in the 1960s. That it's 95 to 97% water efficient, and it's now used in 110 countries. So that's a positive thing. But the one big issue with agriculture is what consumers want. So for 1 kilo of beef, that's 2.2 pounds, uses 15,415 liters of water. So almost 400 gallons. Okay? For,
You mean in rainfall to grow the grass?
yes, they total estimation of everything that's needed to put that beef in the supermarket.
so
And let's not-
grass, corn,
Yeah,
water.
everything.
alfalfa.
And then don't forget that it's estimated that a third of food in this country is lost in waste. From the production to the distribution to the retail to the home, people throwing out food. Okay, for avocados that, in this country, people went berserk for avocados. So the increase was over 300% in just 5 years, to 2010 to 2015. So places like Mexico and Chile and others deforested land, which is not good in terms of water conservation. But 1 kilo of avocado needs 2,000 liters of water. Okay, and just well, the good news about, say, lithium, 1 ton of lithium, it varies from 500,000 gallons of water to 2 million, depending where it's being resourced from.
That means the
To
market
produce,
The mining, I mean.
yeah, to produce just 1 ton.
Yeah.
So, and that's why, the reason that we're using lithium is because the lithium technology first evolved, but sodium, which is everywhere, and easily mineable, and, sodium batteries, which the Chinese are starting to make, just about every country could make without worrying about rare earth materials, etc. Would be about 90% more efficient.
Yeah, but the technology is not there yet.
Well, in China, there are a couple companies that are actually producing sodium batteries for cars. So
Yeah.
anyway, there's good news and bad news in all of it, but
Right.
desalinization, I was surprised to learn there's over 1,600 desalinization plants, mostly concentrated in North Africa and the Middle East. And in Israel, over 50% of it is from desalinization and reusable wastewater. In Singapore, they have a company called New Water, just one word. And it supplies 30% of the drinking water, which comes from sewage.
But looking at all that waste that you saw that we have, and there is so much room for improvement that, I'm sort of positive about this idea, positive about the future of water resources. I think that as a planet, I think we'll be able to do it right.
I'm kind of interested in the low hanging fruit. And a few years ago, some water bottling company got permission to pump, I think, 1 million gallons a day out of the aquifer up in kind of North Florida, Suwannee area. And with very little public blowback, probably a little political payoff somewhere along the line, because it's pretty quiet how it all happened. But what recourse does the public have when you have a company come in and for virtually no investment at all, start pumping 1 million gallons of our water for their own profit? I mean,
Oh, well, they've got permission from some agency to do that.
Do you have to
the
get
county.
permission to drill a well in Winter Park? I mean, a lot of my neighbors are using that to irrigate their lawns. And I don't know, I mean, this is probably in the 70s they got the permission. I don't know if it's allowed anymore. I don't know, does anybody know? Is it
It's
still allowed?
grandfathered in if you've got one.
Yeah, but is it allowed anymore to do?
I think so.
I know I got a note from Winter Park water people, and they said I had a leak. So they track your house, and they said, oh, listen. And they said, if you'll fix it, then we'll go back and look at your water usage, and we'll make some corrections to encourage me to correct the leak.
Well, I lived in the developing countries. I lived in Venezuela for a while, and I visited many others. And this is why I emphasized my view that developing countries have bigger problems than developed countries in terms of wastewater or wasting water. There is that big city of Mexico with how many, 25 million people now? And they have an aqueduct, or a couple of aqueducts that reach the city, but they leak like crazy. They lose so much water just getting the water into the city.
Their pipes or people stealing the water?
Both.
Maybe the Romans should build it.
There you go.
well, I'm wondering, can you count when people steal water? Oh, I'm sorry. When people steal water, it's actually water being used. So would you still consider it waste necessarily, or
No, if it's stolen, yes.
why? I mean, they'd have to use this water anyway.
I have to pay for it.
Well, yeah, I mean, in that sense, but I mean, as far as,
So here's that concept of raising the price of all water.
Yeah.
Significantly,
that seems like a good idea to me.
okay? And so this fits in with that. If you steal water, well, you're not paying your dues to the society, because you're using water without paying, so.
Yeah, well, the only thing, if you think about the same volume of water is used, whether, it's paid for or it's not paid for, is what I'm thinking. I'm just considering that water is a resource in itself. It's gonna be the same. The
Well,
water company's
There will be
gonna,
more water for somebody else who pays for it.
okay.
we could use a lot of recycled water. This is a source of pure water.
That is the key. That is the key, and that is what is being done in many countries. Recycle, recycle, recycle. That is the solution, or one of the big solutions for water waste. Recycle, yes.
When we get into water distribution as a cost, that's using your present supply. It's not really changing, it's just trying to minimize the use of it. But it might, well, while it might work in some developed economies, it's problematic in countries where the question is, should we keep it public or should we privatize? And there's a big argument about that, because if it's public, it's cheaper. If they privatize, the idea is, well, they'll get out to more places. Poorer countries don't have the wherewithal to distribute distribute water in this sense. They can't put in the pipes, they don't have the infrastructure. However, what happens then is that the private companies don't go where they're not going to make a profit. So you have pockets everywhere of people who are not getting money, so or are not getting water. In the United States, if you remember with Flint, Michigan, a lot of folks were having their water turned off. And that became controversy because the question is, could they pay for the water? Low-income people, could they pay for the water? So in southern state, and I can't remember which one, they actually did try this incentive of, we'll charge more if you use more water. And the public utility providing the water was starting to have problems because the revenue went down. So now they were having trouble keeping up with running the plant. So I think when we get into the idea of using cost to minimize the use of water, you need to consider who's gonna be left out, and what people are not really gonna be able to pay for it, and how is gonna be successful in other countries other than the US.
Well, I guess that's what governments are there for, in order to make that distribution proper.
One of the important things, I think, is recharging the aquifer. We said it's not taking too much time to get in, but part of it is taking wetlands out of the equation. And a few years ago, the EPA changed their ruling from it was a wetland if it was wet one day out of the year to it was a wetland if it was, it was developable if it was dry one day out of the year. So that potentially had the effect of taking millions of acres of wetlands out of the equation. In Florida, they're talking about building a development down along the Jingle Creek area and taking wetlands out and justifying it because they're going to consolidate some of the wetlands, so they should be allowed to develop other parts of wetlands. But I just think that there has to be stronger identification that wetlands have to be saved. Like when Disney built Celebration, it was a major sink for getting back into the aquifer, and they, I think, donated 5,200 acres of dry land where no water percolates back in, and took a major sink out of the aquifer. So I just feel like we're kind of looking in the wrong areas. First we have to start protecting the wetlands so we can keep recharging the aquifer, and then solve other problems. Thank you.
I think that may have involved court action. And as you recall, a case went to the Supreme Court where what was a navigable water and what was not navigable water was disputed. And I think there's been some retraction on the authority of the EPA to regulate that has resulted as a matter of court cases. But it has been happening, but I think it's not necessarily within EPA's decision-making wish in that respect.
Well, I think the main problem is politicizing the EPA when the EPA is trying to do science. I think now the Supreme Court rolled it back a little bit, and there has to be some contiguous area or something to be a wetland, so that wetlands that are kind of geographically not communicating with one. I don't know the law behind it, but I'm just saying there's a lot of politicization of water. I think water should be less political and look at the science. That'll never happen.
In the same article that
Steve was using in the presentation, related to what you're saying, it cites that one of the biggest obstacles is that the depletion of this unseen yet essential natural resource is barely regulated. The federal government plays no role. They describe it as a dizzying array of weak rules across states and regions. So there's no overruling body. In the comments section of this same series, a lot of people responded, but they talked again about the agricultural use and how if we just reduced beef consumption, because of most of the farms, I guess, are growing alfalfa for the beef. I think also in this set of articles, as well as one addressing more of the Florida problems, they said that watering of private lawns and golf courses, obviously that's a big issue in Florida. And related to the depletion of the aquifers, as you said, with fracking, when we lived in Collier County for about 17 years, the last 5 years, which was about 3 years ago, Collier County, Naples, Fort Myers region, which on your map, I think it was Tampa that showed a lot more of the aquifer areas. There were many groups fighting the fracking because there had been fracking wells all to the western part of the Everglades for many years. And many conservation groups were protesting the increase in what were proposed to be fracking wells. But I think they basically won, because of this issue of water, as well as contaminating the limestone or whatever. But let's see, many of the Florida articles will also talk about what is it called? Not sedimentation, subsistence. For a lot of the real estate across the coast, they'll build seawalls, but then that affects the natural flow of the water, and then you get salt water into the aquifers. But it's endless. I think it's pretty depressing. But I know that they always will quote Hawking as saying, we got to get to Mars. We got to find water, other water sources. And then I'm surprised they didn't address plastic, of course. I mean, people are working on something that will eat plastic so that we don't continue to damage the.
That's another subject.
Yeah.
I don't know if any of you've been to the Waterlands Park, and it's quite interesting. It's where we take our sewage and we process it. We went to the art exploration group was invited to go on that last spring, and so we went out, and it's quite interesting. They treat it before they leave for bacteria, but what they can't remove are some of the medications that stay in the water. But it's quite an interesting thing. It's built on sort of downhill, so it's all done, and it kind of goes in, and then it eventually goes into the stream, and it's in the St. Johns River. Yeah, but it's really quite interesting to go. A lot of birders go out there, and it's not smelly.
Yeah, on that note,
and you mentioned it. So in India, there's over 400 million people who live along the Ganges, the holiest, and the biggest religious festival, 150 million people go there. You're allowed 40 seconds in the river, but the Ganges is immensely polluted. So the water along the Ganges and other tributaries have 1.6 billion fecal coliform per 100 milliliters. Okay, and the Indian government recommends no more than 500. Yeah. So the one of the problems is the hydroelectrical dams reduce the flows, and they assumed that the glaciers would melt and increase the flows, but actually the reverse has occurred because the aquifers are declining at such a rapid rate. Now, one of the other things is that in the aquifers, the deeper you go, the more chemical concentration there is, especially arsenic. It's a huge problem. In
naturally occurring arsenic.
Yes, but then in polluted places, from industrial production, in the area of Churaman Nagar, the concentration of naturally created fluoride reached a level of 16 milligrams per liter versus the US limit of no more than 1.5 milligrams, which caused skeletal fluorosis affecting millions and millions of people. So this is another thing. The deeper you go in the aquifer, the more concentration of both naturally and industrial pollutants, because they're denser. So what I was fascinated, there was a comparison between India and Israel. In 1939, there were 834,000 people dependent on the Jordan River and the Galilee. There are now 14 million people in the same area, but 50% of the water comes from desalination plants that are from private, because the government won't shell out the money. They charge for the water, but it's not a ridiculous cost, but enough for them to stay in business and regulated by the government. So there are solutions. There really are, and we just waste water because there's no cost. And lastly, human beings feel they have a human right to water. Yeah, because just like the seas or the earth, we're 70% water, just like the earth.
I have more, just a little.
About the aquifers, there is a particular problem with the aquifers that if you let it go down too far, then the aquifer will collapse. And there is no way to recover that. And as a matter of fact, in the article about Iran, I think it was our article, or it's a similar article, they said that in Iran, the problem is that all their aquifers, or most of their aquifers, have been exhausted and have collapsed. So that is irreversibly losing even the potential of reserving or getting water reserves.
I was just gonna add a couple more comments about Florida's conservation efforts. I don't know which administration, but they've been trying to get, there was a big efficiency law that had to do with water friendly water days, as far as watering your lawn. And of course, I'm sure people have heard about taking shorter showers, not flushing all the time. Related to the other developing world, you probably know Bill Gates, that's one of his big projects, is composting toilets in the developing world. So I mean, and then I don't know, the toilets in here, they're called WaterSense toilets. They're
Number one.
yeah. So they want everybody to get more efficient, less water intensive appliances and things. So I just trying to think of, who to best vote for coming up in elections, at least in Florida, in terms of water.
Yeah, here's something that we haven't spoken about yet. And that is the development of forever chemicals that was used for Teflon. And that poisons the water and creates cancer. And there's been some suits and so on. But what the EPA has done was raise the tolerance level, which doesn't seem like a really good idea. They can't get rid of them. So they just raise the tolerance level and say, well, it's okay if it's this percentage. So I don't know if anybody knows anything that's been done with that, but that's kind of worrisome, isn't it? That they produce these forever chemicals. I think they're volatile hydrocarbons. I don't know much chemistry.
Fluorine hydrocarbons.
Thank you. And I'll leave it to you then.
Well, I don't know what they're doing about it. Teflon is tetrafluoromethane or ethane, and fluorine, of course, is a nasty chemical if you take too much of it. If you take the right amounts, it improves your teeth, right?
I don't think it's good anyway.
No? Okay. Yes,
On the subject of toilets,
Also good news. So in India, this surprised me. There were 600 million open defecation sites. Okay, which represented 60% of the total. In the last 10 years, they've installed 92 million toilets that turn fecal matter into compost. So, the technology is changing constantly. And, I remember being in China, if you drove on a road, there'd be competition for any individual needing to take a dump. And there was competition because they would compost it and use it. They paid.
I remember,
the problem is,
this was a long time ago. I remember that in the chemistry department, we had a guest who was going to talk about the chemistry of, well, human waste. And so I started talking and he explained that, he had to go to India. That's where he could study these things because there was open defecation. So, just get your shovel and go there, run after the guy who just finished it and pick it up, and then they will weigh it and this and that and do all the research on it.
Tell them about Carlos' time in Afghanistan.
Oh, that's another, so that's different though. The United States tried to introduce modern buildings into Afghanistan. My son was a lieutenant colonel in Afghanistan at that time, and he was part of this program to build, housing and toilets for Afghanis. And so they did a whole bunch of them, and then they found that there was a problem. And the toilets somehow got full of stones, bigger stones. And so they couldn't figure out at the beginning why that was. And finally, they did. It turns out that Afghanis use stones to wipe themselves.
all over the Middle East, where it's desert.
And so they finish the stone and then throw it into the toilet.
Thank you, ecotourism was mentioned in the list of solutions, and I back in the day I had covered ecotourism a bit, and I was looking it up to see what was new. And there's this site that talks about the United Nations efforts for ecotourism, so forth and so on. And here's a question for you: if you are planning an ecotourism trip, your first challenge is to this tells you, select an airline. Always prefer to choose the eco-responsible airline. So I throw it to all of you. Do you know what that is, the eco-responsible airline? And how would you choose one? There you go. That's my question.
I don't know. Eco-responsible airline, I don't know.
I think sometimes they ask you if you want to donate towards something when they don't fly.
Wait, there's an answer in this room. Go ahead.
Whichever one doesn't de-ice, so you can't go somewhere that was up on the sheet.
It was up there.
Yes.
Then it's not safe to fly.
That's a trade-off.
We were visiting some relatives in Austin, Texas, a couple of weeks ago. And my brother-in-law was telling me about, all the water problems out there in the West, Midwest and West. And one of the big things they're facing is years ago, 100, 150, 125 years ago, there was a lot of water rights laws that came about. And so what's happening is in Texas and Arizona, New Mexico, California, big landowners have a right to all the water underneath their property. And so they can take as much as they want. And that leaves a lot less downstream of an aquifer or whatever for other people. So it's really exacerbated, governments and all trying to allocate water and, be more optimized about water. So it's become a huge problem out in the West.
Well, I'll tell you two stories about our travels. First, when I was asked Eileen to marry me, I told her I traveled, and if you don't want to travel, say no. We have traveled. One story was southern Turkey. The water was about a mile away, and the ladies had to go get water and carry it back. They solved the problem. If you guys don't put a pump in and a faucet here, there'll be no more conjugal experiences. They had water within a couple of weeks. The second one was, I believe it was the Ganges River in China. They built a dam and they flooded the valley. And the people who lived in the valley and farmed in the valley had to go up to the sides of the valley or they would drown. Then periodically the dam would open and the water would go out. And all the debris that had settled to the bottom of the river suddenly was fertilized. So they came down from the top of the valley into the valley. They did their farming, they did their harvesting, then they got the hell out.
Thank you.
Yeah, one issue that we haven't touched upon is that 9 countries have 60% or more of all water resources. Okay,
9 countries.
9 countries. Now, China and India combined have 38% of the world's population. They only have 11% of the world's water resource. So there is an issue. For example, when Ethiopia builds a big Renaissance dam on the Blue Nile, the Sudanese and the Egyptians feel threatened by it. India and Bangladesh is, potentially there could be a war breaking out because the Brahmaputra River, the Chinese are diverting the water because they want to take care of their own people. The Pakistanis and the Indians have an issue with regards to rights to the Indus River. And of course, the Euphrates and Tigris River, Turkey, Iraq, and Syria, there's no treaties on them, and it's potentially a huge issue. So, not to put a damper on things, but, there's also the potential for conflicts between countries over access to water.
Absolutely. Okay, well, thank you very much for coming. Next week. Next month, we'll have a video here about the potential nuclear war situation in the world. It's not war. It's the nuclear tensions, let's say it that way, in the world. So that's going to be next month. We'll see the video and then have a discussion. Thank you very much.
Of course, Steve.
I had.
Yeah, that is if we don't have a nuclear war by then.
Hello, Bill.
Yeah.
No, Bill, we don't.
I had a list of everyone who wanted a book and somehow it got lost. So raise your hand if you want a book. Jerry?
It's this book here that you're ordering. What's
Great
that?
decision.
Between 27 and 30 some dollars or how much?
It's $28. Well, actually, no, it's too late to order them at the discount price right now. So it's, I don't know, $30 or something. Tim, you want one?
Yeah.
Who else?
Joanne.
Okay. I got you, Perry.
Okay, that's good. And remember, when you're brushing your teeth, turn off the water. Bye, guys.